pleasure to introduce Pooja Shaker, who will tell us a little bit more about Dr. Glazer's work in STEM education across the region. Pooja actually spoke for us last year for the STEM Symposium and is the famed Thomas Jefferson High School graduate who was accepted to all 8 Ivy League schools. Back due to incredible popular demand, Pooja is joining us on her spring break as a freshman at Harvard University. Pooja is concentrating in biomedical engineering with a secondary degree in global health and health policy. She continues to run at the national nonprofit Project CS Girls, a program that is closing the tech gender gap and runs computer science competitions for middle school girls. Pooja?
Thank you so much, Bryn. So my name is Pooja Shaker, and I graduated from Thomas Jefferson last year and from Naismith in 2011, I think. Okay, so I'm like super excited to be back, and I'm so honored to introduce my former principal, Dr. Glazer, as he gives his keynote address. So I just wanted to take a little bit of time and talk about what Dr. Glazer has done for me, for his students, and really about the little things. And that's what I think matters to me and to most of his students. So as most of you probably know, Dr. Glazer is the principal of TJ. And one of TJ's biggest strengths is science and technology, and Dr. Glazer has really been a stronghold for that. His endless support of our science program, of our technology program, of implementing new science and technology classes, of making it a more inclusive environment has been incredibly important to pushing TJ as a school, to pushing TJ students forward, and really empowering more students to take up an interest in STEM and technology in the Fairfax County area. So one of the first things that struck me about Dr. Glazer, I guess after my sophomore year of high school, so that was when I first interned at the MITRE Corporation, which some of you may know, it's in McLean, and I spent 3 summers there. So and it's not that big of an internship program in that there's only around, at most, 15 students every year in that program who intern at MITRE. Yet, every summer, Dr. Glazer took the time to come to MITRE's final review and listen to each one of our presentations. He was so excited that every time a TJ student presented, he was like, and every time like one of us left the room, he would come out and talk to us and tell us what a great job we did. And just something little like that makes such a huge difference in empowering us and making us feel so much more confident in our abilities. The next thing is that he is so involved in every aspect of TJ's culture. He's not just a principal who just sits in his office. He takes part in every part of our school's activities, from dressing up for Halloween, which is great, to participating in J-Day, to being part of TJ Star, to being part of Hack TJ. He is just such an integral part of our school's culture, and his every morning he signs off with "Go Colonials," and I really miss that. And I think that's something that every TJ graduate carries with them through to college. And from that, he's always so connected to his students, not just during their time at TJ, but even after leaving TJ. He's always so connected, and he'll take the time to listen to you. And that was another thing that I wanted to touch on. Throughout my time at TJ, I could count on Dr. Glazer to any time I wanted to talk about something. Say, for example, that I wanted to talk about Project CS Girls or a program that I wanted to launch for Project CS Girls. I could always schedule a meeting with him. He was always available, and he would just take the time to talk and see how he could help support it, how he could help spread the word. And that's really important, because if you have a principal who is dedicated to pushing his students' success and to celebrating his students' success and to really striving to help out in any way he can, that is so, so helpful and powerful. And just, I'd like to end, I don't want to take too much of your time, but just to thank Dr. Glazer for being a wonderful mentor to me, to all of your students, and just for always being there for us and for making TJ what it really is and making such a huge crowd come out to see you. And that's just because of the work that you've done for TJ. Thank you so much.
Oh, thank you, Pooja. You started making me tear up. It's hard to get all emotional before a presentation. Um, Pooja is one of many remarkable students and dedicated students. And of course, as a principal, when you have students who have ideas and they want to do great things and have an impact on society, you want to make the time and feel inspired by what they do. So Pooja's work with Project CS Girls is a mentoring program that's nationwide. She was drawing in students' interest in computer science and engineering and pairing them with mentors from all over the country. It's truly a remarkable work. And she's so dedicated in so many facets. She wanted to help out at the STEM Symposium today. This is her first day of her spring break. Can you imagine, like, you're a college student, your first day is spring break, and you come to a STEM Symposium instead of hit the beach. So let's thank Pooja for coming out and helping. I'm glad that you're doing such great work at Harvard. It doesn't surprise me. So I'm here to talk about how STEM opportunities shape continued interest in STEM. I'm going to talk a little bit about research. I want to get your opinion. I'll do some polling. Really wanted to give you kind of the landscape of what gets people engaged in STEM and continuing to keep going. And I apologize, my voice is a little froggy this morning because of allergies, but I have 2 different drinks up there that'll keep me going. Let's see, where do I point this? Towards you? There we go. Okay, so I think the goals when we think about why do we get people involved in STEM are multifaceted. Do we want to promote innovation, get a good job, improve society, increase our workforce? These are all very noble causes of getting involved in STEM, without question. In my household, I'm just, oops. Let's see if I get this the right way. There we go. In my household, I'm just interested in getting my kid interested in learning. So that's Luke, my 2-year-old, and of course I want to find out ways to get him engaged in learning, and one of them is through STEM. And I'm so glad to see a poster of myself. I've never had a poster of myself, and they told me I can take one home, which is great because anytime I'm away, like if I have to go to a conference or whatever, I can just put the poster in his room and say, I'm looking after you. You better watch yourself. Make sure you learn. I think I lost a slide here. Oh, there. Oh, sorry. Let's see if we can get this back. There we go. Okay. So on a more serious note, I'm dedicated to advancing education, not just at TJ, but in terms of the work that we do as a regional school and providing opportunities for kids far beyond TJ and getting them engaged in STEM. It's a very important cause because there are some serious problems in the U.S. And this 2-minute video will kind of portray some stats that give us a cause for action. All right, so when you see a video like that and stats like that, it hopefully gives you perspective of, we really need a lot of people involved in STEM because there's some significant challenges ahead, not just in our performance as a country, but also equity issues that need to be addressed, because we're going to broaden our quality of STEM programs and our STEM work in the workforce if we broaden the diversity in the engagement with underrepresented populations. So there are 6 key factors that motivate people to go into STEM. And when I use STEM, it's referencing to science, technology, engineering, and math. The motivating factor for me to be an educator is for the reasons that Congressman Connolly mentioned before, that I believe education is a pathway that will make a big difference, but there are a lot of informal pathways outside of education. I'm going to share both today. So those are 6. I'm going to run through them real quickly, and then I'm going to ask you to vote. I'm going to ask you to vote on which of these factors, if you are a STEM professional or if you're a student who's interested in science, technology, engineering, or math, why? What stands out? Which of these factors really stands out to you as being the key factor of why you would want to go and pursue STEM? Okay? So number 1, this awareness of career opportunities. Sometimes people don't even know what opportunities are out there until someone tells you about them. Some of these job titles have fancy names and you don't really realize it unless someone tells you, like a parent or a teacher or someone. Number 2, academic preparation and achievement. So that's mostly what people are doing in schools, how you're learning in schools, how you would get excited about STEM. Those pictures, I'm guessing, are from Naismith. They are pretty awesome to make you wonder that there's some really cool things that are going on in science classrooms at this school. 3rd, identification with STEM careers. Some students or some professionals will say, you know what, I'm a female, but I don't really see female computer science. I don't know any computer scientists. They're not for me. They don't get interested in the subject until they have a great role model. And that's why Pooja, in my opinion, was doing some really interesting work. She was trying to promote getting girls interested in computer science and engineering by having role models who could help them see, yeah, they're in my shoes. I kind of relate to them. Could be associated with being a female, could be associated with a race, religion, a culture. It could really vary, but if you identify yourself, if you see someone who is like you and you see them in that career path, then that's number 3. Number 4, self-efficacy implies that you have the that you have the confidence in yourself that you can do it. Okay? That you have the confidence, I really like robotics, I really like engineering, I really like math, I can do this stuff. I'm going to keep at it. Versus some people who are like, I can't do this stuff, so I'm not interested. Number 5, the external environmental factors. So that's usually other people outside of the house, outside of the school, other people in your life who have made a difference. And if other people in your life who have made a difference to motivate you, or even activities, museums, anything that's outside of your direct influence, whether it be school or parents, that promote interest. And then number 6 is just personal enjoyment. Hey, I love this stuff. I have some kits at home that I was given as a gift, and I just love playing with it. That's what got me excited, just by the subject. I was always curious when I was younger. I was into dinosaurs when I was 5, and it still hasn't left. So I've always been interested. Those are 6 factors that are identified in the literature of what keeps people interested in STEM. All right, so now I'm going to ask you to vote. I want to know which of those, if you are interested in STEM, really stood out and made a difference, okay? Whether you're an adult or whether you're currently a student, okay? So raise your hand if you thought number 1. You had this awareness, okay? Okay, good. Number 2, raise your hand if you thought number 2. All right, raise your hand if you thought number 3. Okay, a few of you. Number 4, raise your hand, number 4. I can do this. All right, number 5. Okay, and then number 6. Oh, wow, look at that. Okay, so I'll say number 6 is the predominant factor. And then there were hands that were raised for all the other 5. So they're all important. I don't have the research that shows which one's most important, but my anecdotal feedback is number 6 is pretty darn important. Okay, so I'm going to talk about each of these. There are barriers to every one of them, so my presentation is really talking about what are the barriers and how do we address them. All right, so the first one, awareness of career opportunities. So there are a lot of available job openings, but there's this considerable gap in skills. It's very evident, particularly in specialized positions that require a graduate degree. And so we have career fairs to get students interested as early as the elementary level. But a lot of times people don't know what different careers are about. So there's a few pathways to explore. One is you can go online, and then there are other types of assessments where you can answer a series of questions, and it can give you an idea of what you might be interested in exploring. So if you're not aware of, hey, I like STEM, but I don't know what to do, take an assessment. And some of those assessments are available at schools. You know, like I know there's one available at my school. But check it out. And then there are some organizations that will try and spread awareness. So I think Pooja's Project CS Girls was one of them. There's another group that's here today called Project Codit, and they are giving a workshop today, in fact, and they're trying to promote awareness among females in computer science. We really want girls to understand that they're instrumental in the field of computer science. So there are special interest groups that try to help students develop that interest in different career opportunities. There are many different theories surrounding student career decisions. I am not going to tell you that one is better than the other, but I will leave you access to my slides, and you can pursue any of those further if you'd like, if you're curious. Now here's an interesting study. So some people may say, well, based on student interest, because student interest usually develops in late elementary school and early middle school about what do you want to do for your career. Now most people don't always keep that in mind, and here is actually a study that was conducted in 2006, so about 10 years ago, that actually tracked students when they were in middle school all the way until they finished their college degree, you know, and chose career selections. And they saw some patterns associated with students who identified an interest in science in particular, science and engineering, versus those who didn't. So the left-hand chart is a chart that displays the students who identify themselves as being interested in science and engineering. They said, in middle school, I want to go into science and engineering. The right-hand side is the students who said, I don't have any interest in science and engineering. And then the colors on the chart represent what the decisions that students made. So the really light color at the top, those are students who didn't go into science or engineering. So you can see that if a student decides in middle school, you know, I don't want to go into science and engineering, they're more likely not to go into science and engineering. But it's not exclusive. You can see from the chart that a third of the students in middle school who said, I didn't want to go into science and engineering, still decided to go into science and engineering. There was something that influenced them along the way. Okay, so it's not like it's a done deal. And in the same vein, you know, about half to two-thirds of the students, about half of the students decided to choose STEM once they kind of said they were interested in middle school. And then the difference between the dark green and the light green, the dark green is hard sciences like physics, engineering, and math. The light green is biological sciences. And then the x-axis, the independent axis, shows math achievement score. They're trying to see if there's a pattern that how students do in math, if they're going to make decisions that lean towards hard sciences or biological sciences. And you can see from that chart, yeah, there's a pattern, sure. Students who tend to do better in math, sure enough, are more likely to choose a hard science, except if they're not interested in STEM. You notice the chart on the right? So the students who said, I'm not interested in STEM in middle school, there's just a little bit of a difference. It's much more magnified in the left chart. Okay, so here's a quiz for you. All right? There's 8 fields, STEM fields, that have projected growth. Which of those do you think has the highest? Go ahead and talk to a neighbor. Think about it. I'm going to ask you in 15 seconds to vote. All right, counting down. 5, 4, 3, 2, 1. All right, we're going to vote. So the good news is every single one of these career paths has projected growth in need. They're all needed. There's no decline at all. All right, so I'm going to get you see if anyone got the answer. All right. Number 1, what do you raise your hand? Raise your hand if you think it's the highest. Okay. Number 1. Okay, we got one hand. Number 2. All right. Good number. Number 3, 4, 5, 6, 7. Ooh, this is really tough. Number 8. All right. Well, I have good news for Pooja because the biomedical engineers have an extremely rapid growth rate. You will have no problem getting a job. Yeah, they're all pretty darn good. So some of you might be looking around like, what the heck is a biomedical engineer? And why is there such a high need? And there was a good portion of you that raised your hands. It was like a 3-way tie. You know that we have an aging population of baby boomers in our country, so biomedical engineers are going to contribute to a transformation in advancing the technology used in healthcare, and that is definitely needed at this time. Okay, so in the second category, academic preparation and achievement. So there are some significant barriers, particularly among students who are at a financial disadvantage. Okay, the language that's used is undermatching, that students who are coming from households that don't have resources tend not to even pursue greater challenges. There's all sorts of data talking about not just households that are from free and reduced meal needs, but also barriers associated with underrepresented minorities. There's some pretty strong statistics saying we have a problem. And if we want to broaden the workforce, we need to find ways to motivate underrepresented minorities to get involved in STEM fields. Look at this. This is alarming statistics. Okay, these are college admissions statistics, and this is done by the Jack Henry Cook Foundation. They said, take a look at college admissions, okay, and we're going to rank. We're going to put colleges in 6 different categories, from most competitive down all the way down to community college. And then we're going to look at their quartile, you know, top 25, 25 to 50, 50 to 75, 75 to 100, and where they are in terms of their income level and who's being admitted, okay? So if you look at very competitive, highly competitive, and most competitive, you know, if you look at the lower 50% of the students who are admitted, it's pretty darn small. It's only representing 14%, 20% of the overall admissions to some of the best colleges around the country. Even in competitive, it's signaling that the people with the financial means are able to have the resources to do the appropriate research and create opportunities for kids to get into great colleges. And that's a problem. So I'm thankful that we have symposia like this that's open to everyone, open to the whole public. So the Jack Henry Cook Foundation, for those families that are that do receive free meals, that do qualify for the free meal lunch program, they have a Young Scholars program where they take applicants in 7th grade and follow them all the way to college. They take students who are in the same economic challenges in the college scholarship program, provide tuition and waivers to college to make it extremely affordable, as well as an undergraduate transfer scholarship. It's a great foundation that supports getting students who don't have the financial means to do remarkable things in college. They've even provided my school a grant to offer a middle school program that will encourage students to take on challenging academics. We're really trying to meet kids at their potential. All right, another barrier, without a doubt, stress associated with taking on a lot. So we talk a lot about academic achievement, but sometimes we're not careful about the emotional well-being of how students take on a lot. So a lot of this is about understanding when we need to pull back from overachievement. Okay, so the opportunities. In the state of Virginia, there's 19 STEM schools that are regional governor schools. But even if students don't go to governor schools, you've got Science Olympia and Math Counts, countless activities available to kids. And then even advanced academic programs in different schools. And then there's academy programs. They run Project Lead the Way. In my opinion, it's a great engineering curriculum that will give students hands-on experiences solving engineering problems inside a curriculum. I'm not talking at the STEM schools. I'm talking about at any high school that has an engineering program or a tech ed program. There's a lot of benefit in getting students involved in this curriculum, Project Lead the Way. All right, and then some people say, well, what if you go to a science and technology high school like Thomas Jefferson? What's the influence? There's a national study that looked at that, and students who, when they were entering high school, said, I'm going to this STEM school. A quarter of them say, I'm not interested in STEM, but I still want to go to this school. And then 65%, or excuse me, that's not accurate. That's not how to read the chart. So you have some students who say, I just want to go to this school because I think it's a good school. And you have some kids who say, I really want to pursue STEM as a career, okay? So there's a research study that actually followed kids and saw what they did. So those students who expressed an interest, or those students who wound up finishing an undergraduate degree in science, it was significantly higher than those that didn't. And then as a control group, they compared students who were interested in science but didn't go to a STEM school, and they wanted to see the impact. So you can see that there's a little bit more influence if students say, hey, I want to pursue STEM. There's less influence if they don't say, I want to pursue STEM. So if a student goes to Thomas Jefferson High School for Science and Technology and says, you know, I just want to go there because it's a good school, but I'm not necessarily excited about STEM, it's not going to make a difference. That's what the research said. It's not going to make a difference to encourage them to go into STEM. All right, so now I'm going to ask you for a poll. There are key STEM experiences that happen as a result of this study that influenced students to choose STEM as a career path. So here they are, they go to this STEM school. There's about 100 in the country. You know, North Carolina has a state school. Virginia has 19 regional governor schools. So they ask alumni from these schools, hey, if you went into STEM, what was the influencing factor? And those were the top 4. So talk to a partner, figure out which one you think made the difference, which had the most influence. All right, counting down from your votes, 5, 4, 3, 2, 1. All right, so those were the 4 most influential factors when they contacted alumni from those respective schools. TJ participated in the study, but there's schools like ours across the whole country, okay? So raise your hand if you chose A. Raise your hand if you chose B. Raise your hand if you chose C. Raise your hand if you chose D. All right, the results are going to surprise you. Here they come. This idea of doing a research project really made the difference in students feeling committed to carry on and be interested in STEM. And I will explain why in a different slide. I'll explain why in a different slide. It'll make more sense later. All right, number 3. So there's this identification of STEM careers. Some students identify scientists and engineers as a certain stereotype. So you have Sheldon Cooper from The Big Bang Theory, right? So you get this perception of this is what a scientist and engineer is about, which isn't really the case. There might be some scientists and engineers like him, but it's certainly not representative. So then when you have Marissa Mayer, the CEO from Yahoo, she even makes public statements like, hey, I can't believe people are surprised on why I did so well in math and science. There are these stereotypes that are out there that impact students' ability to identify with different careers. There's plenty of opportunities. This is a great video, but for purposes of time, you can watch that online. Goldie Blocks is the name of a company that promotes engineering toys, engineering activities, particularly to females. And then there are plenty of organizations to promote identification in STEM fields. So Becoming Everything You Are is a great organization to promote African Americans in STEM, as well as the National Society of Black Engineers has a mentoring program. The U.S. Science and Engineering Festival, which is occurring later this spring in the Washington Convention Center. It's free. It's awesome. Don't miss it. It's huge. They have the science cheerleaders that show up, illustrating that if you're a cheerleader, they do that as a hobby, and their real profession is a scientist. So they want students to identify, hey, computer scientists, engineers, they come in all different sexes, races, and there's some inequity, but we want to have good role models out there. All right, now I'm going to get to the point why research makes a big difference. So there's certain barriers that people have associated with self-efficacy. It's their self-confidence and their ability to whether or not they can do math, do science, and so forth. Okay? So real quick poll. Raise your hand if you identify yourself as a math person. Okay, so my contention, as well as Dr. Bowler from Stanford, says everyone is actually a math person. So somehow our society has identified with the idea that, hey, everyone can say, no one's going to raise their hand and say, I'm not a reading, or I'm not a literate person. That's a problem, but there are some people, most people don't say, it doesn't matter if I don't know how to read. But there's a lot of people who say, it doesn't matter if a lot of people aren't bothered by the idea of proudly professing that I was never a math person, I'm not really good at it, and it doesn't really matter because my career doesn't use it. So Jo Bowler, and she's using a lot of Carol Dweck's work out of Stanford on the mindset. And here's the issue. So the best thing that students can experience when they're growing up, if they really want to learn, is actually failure. The best thing that students can experience in terms of helping them develop is failure. And for some reason, our systems are designed to constantly reward success and actually to minimize failure as much as possible, almost like avoiding failure. See, the neuroscience behind the value of failure is that our synapses in our brain will fire more rapidly when we get something wrong. So shouldn't we be focusing on celebrating the things that we get wrong, because those are the best learning experiences? It's actually through our mistakes where we grow the most. And what happens then in schooling is when you're not doing well in math, you just say, I'm not really good at math, I feel embarrassed by this, and then I shut down. So rather than taking advantage of growing from and learning from mistakes, the problem is that people then will just shut down instead of embracing that as a learning experience. Now, of course, educators make the mistake of only pointing to the kids who have the right answers. Okay, it's my job as a principal to say, don't only point to the kids who have the right answers, focus on celebrating the mistakes, because that's when students are really going to grow and learn. But if students feel like they fail and then they just shut down, then of course they're not going to pursue it. And then they're going to say, I'm not a math person because I was never very good at it. And the reality is we should be saying we're all math people because we all have made mistakes in math at some point, and some of us have managed to persevere and learn through those mistakes. Okay, I was a math major. I've made plenty of mistakes in math. I still do. But somehow I've developed the confidence, the self-efficacy that if I keep at it, I'll get it right. And that is huge. That is huge among younger people and also the role modeling that we do as parents. So Paul Tough wrote a book also a couple years ago about grit, curiosity. It's a great read. It talks about why children succeed. And the primary reason why kids succeed is that they stick with their failures and they overcome them. So they don't get have setbacks and just quit. They actually have role models in their life who are telling them, look, you don't get it? No problem. Keep at it. If your effort enables you to get through your failure, that is what's going to help you succeed. The worst thing that we can do as parents is only pointing to the things that kids are great at and tell them they're brilliant. They're not brilliant for the sake of genes. Sorry. I mean, maybe partially, but really not. Okay? You get great at something because you put the time into it, and when you had a setback, you kept at it and you kept getting better and better and better. That is the key to overcoming those barriers. That's the key. So those are great reads if you want to check out that further. So this was interesting. This is a while back. Some of you might remember this if you're a parent in the early 90s where Barbie said, math class is tough. And all the math teachers got really angry, and then they discontinued the Barbie doll that made that statement. It made made the news and everything. And I have mixed feelings about this because I think it's okay that math class is tough, and that why not? If you're a male, female, doesn't matter what you look like, that you want to stick with it. So if she said math class is tough and I'm sticking with it, then of course that would have been a lot better. So the opportunities. This is where it goes to science research. Okay, you remember earlier you raised or very few people actually raised their hand, and the research says that if you're involved in a science research project, it at least propelled the kids who were in STEM schools to continue on to STEM careers. And the reason is because those students actually immerse themselves completely. They cope with failure and they overcome it because they keep working at it. They keep working at it. Science fair project isn't done overnight. It's done over months and sometimes a year. As professional, it's done over years. And some of the best research projects, even in high school, are done over years. So it's working on a project, having setbacks on the project, not doing very well, getting help, making progress, starting to feel like, wow, I'm making progress, because it's that setback. Once a student isn't making progress, they're going to want to look for help. They're either going to shut down or someone's going to say, stick with it, you're going to keep at it. And the process of sticking with it and keeping at it and realizing you can learn if you stick and keep at it, that is extremely memorable. Remember earlier I said, the neuroscience says when you make mistakes, the synapses are firing. They're firing. You want to know what's going on. And then as soon as you realize how to correct that mistake, boom, you stick with it. And then you actually become more courageous to accept more mistakes and to realize this whole process involves mistakes. But if I keep at it, I'm going to get to a really interesting outcome. So if you want to improve efficacy, if someone has doubt in your home about whether or not they can do math or science, give them something that they can stick with for a while. First, robotics is great. There's plenty of robotics examples. I think that's the same thing. When you engineer something, it fails right away. I've never been part of an engineering process where it worked the first time. And that's wonderful when someone has to go through 100 iterations and learn through that. All right, external environmental factors. So it's the internal environmental factors that sometimes parents are saying things about math and science and STEM that impacts students' realization of their abilities. Parents, particularly dads, tend to underestimate females' ability in math. There's plenty of research surrounding that. I'm not pointing fingers at any dad in the room, but I just want to let you know there's plenty of research surrounding that. And the same thing in Freakonomics, there's a great chapter about parenting. Your role modeling behavior is the largest influence on what's going to help students develop really good habits. So if you tell a kid, hey, you got to read, if they don't see you reading, they're not likely going to read. Okay? If they see you on your phone all the time, guess what? They're going to want their own phone. I see students nudging their parents right now. Okay? Okay, if you want your children to develop really good habits, they're looking for you to role model them. That's the barrier, is if we as adults model behaviors and then tell our children something else. Okay, there's plenty of opportunities of great role models. Elementary school, there's a lot of pairing with, we have a STEM Ambassadors program, for example, at TJ. There are great internship programs. Pooja mentioned the one at MITRE. There's a huge one with George Mason University called ASIP. There are internship programs around the country. Getting to know scientists, engineers, and the work they do certainly has a big influence. All right, I'm wrapping up. Let's do one more survey. Actually, we don't have time to do this survey, so I'll just tell you the answer. So there's an interesting research study about outstanding role models of people who have been awarded a presidential awardee for their mentoring, particularly towards underrepresented minorities. And they asked them, what is it in your practices that you feel makes the largest difference in helping inspire another generation of people to go in the same direction you did? And here's what the top 5 factors were. The ones that stand out are being passionate about the development of the mentees and creating opportunities for the mentees are most influential. TJ actually has a mentoring program for an electronic system that we're ready to roll out. That is a way in which professional mentors can interact with our students, and our students can interact with younger students in a safe, secure, confidential environment. Okay, the last one, interest, enjoyment, and motivation. Okay, this is where most of you raised your hand. Okay, there's plenty of barriers to interest. One of them is just having access to opportunity. The second, I think, is portrayed well in the movie The Three Idiots. Raise your hand if you've seen that movie, The Three Idiots. Okay, a decent amount of you, particularly those who are of Indian heritage. It is an Indian movie, okay, but it's a fantastic movie. It's probably available on Netflix or whatever service that you use. It's really a fantastic movie, and the reason why it's fantastic is because you have 3 students who are at this university, IIT. It's great in India. But they don't all want to be there. They don't all love science and engineering. And what's fascinating is you see how they cope with it, because their parents say, you need to go to this school, you need to be an engineer, we need, this is going to give you more respect in society. And the students cope with that in different ways. It's a great watch for parents, or if you're above 13, because there's some silliness in there that makes it PG-13. Okay, and then there's plenty of great opportunities that spark interest. George Mason University has a wonderful STEM program for elementary age students. We run middle school camps over the summer. We run hackathons. Our students run hackathons for middle schoolers. There's great stuff all over the place to engage student interest in STEM. Okay, so those are the 6 primary factors. Just as a quick recap, there are plenty of great opportunities available to get you or your kids involved. I highlighted a few examples, and I want to finish with one video to show you, not that one, yeah, one important factor
Wondering why the younger generations
that's important for
aren't
younger
pursuing
kids.
some of the most in-demand and high-paying careers? Well, we are too. So we asked a group of students to help us get to the bottom of it. The results are interesting. Here's how it worked. We provided a series of job titles and asked the kids to place them on the scale according to how cool they think each job is. Then we had them repeat the process, only this time we used an image to represent each job. We chose not to mention that they were actually the same jobs from the first exercise. The rankings for well-known careers like doctors, teachers, and carpenters remain relatively consistent in each exercise. However, the rankings for the STEM careers, they changed quite a bit. Why? Well, let's take mechanical engineer for example. What do you think a mechanical engineer does?
Fixes... invents mechanical things like a football helmet, like anything. They fix mechanical stuff, like a mechanical bull or something. Things with technology.
And sort of, not really, but maybe fixes up a couple plumbing things.
Yeah, builds them a little bit.
If nobody knows what these careers are all about, how will they know if it's something they'd be interested in? As a country, we need more science, technology, engineering, and mathematics professionals. Employers are struggling to find the right talent to fill their open positions. Yet, only 6% of today's high school seniors will get a bachelor's degree in a STEM discipline. So what can we do? Inspire the younger generations to follow their passions while exploring fields that set them up for success. A career in a STEM field can be exciting, in demand, and in many ways part of something they're already passionate about. Help us shape the world of work.
So sometimes it's just a matter of making our students and kids aware of what these jobs and what these amazing careers are all about. And a STEM symposium that we have today is a great way to get started. So thank you very much. If you'd like to access my slides, I've posted them online. By all means, feel free to check them out, and you send me a question as you have them. Thank you.
Dr. Glazer, I'd like to thank you very much. He will be available for questions at a panel at 2 o'clock, plus he's going to be walking around a little bit. 1 o'clock, we have our astronaut, Dr. Sadney Magnus, is going to be here, talk a little bit about her last flight, and at 2 o'clock, Dr. Glazer back on the stage. Thank you. Have a good STEM symposium.